Hello, welcome back to the channel. So till now we have covered all the symmetry operations that can be performed on a molecule. Now in this particular video, what I'll be taking is, so if we repeat the symmetry operation, any given symmetry operation for n times, what will be the outcome of that? So that aspect it will be discussed in this video. Okay, first thing, see, these are the relationships that I'm going to illustrate in this particular video. If you already know these relationships, or say if you can convince yourself easily that these relationships, they are definitely valid. So in that case, it's not necessary to continue with this video. You can just stop watching this video here itself. So because here I'm not providing any mathematical evidence or proof for these relationships. So just to convince ourselves that these relationships, they're right. So what I do is I take some examples, and the examples that I have taken already, these examples they have been cited for demonstrating different kind of symmetry elements, same molecules I'm taking, and with the help of the molecules or by performing these operations on the molecules, we shall just try to convince that these relationships, whatever I have mentioned, they are really valid. Only that part it will be taken here. Okay, let's begin. So first one, say Cn raised to n, it is E. So this refers to, say, any operation, any proper access operation, if it is repeated for n number of times, where n is equal to the order of access. In such case, this results in E when n is even. That point is being seen here. See, this is orientation 1 of water molecule, and if I perform C2 operation, it is C21. In fact, C21 it says it is 180-degree rotation. So the molecule, it changes its orientation from this orientation to this orientation. Let me call this orientation as orientation B. Position of HA and HB, it has been interchanged. Now on this molecule, I perform the C2 operation again. So again, one more time I perform C2 operation. So with respect to this, it is C2 operation, and the molecule it changes to this orientation. Now if I come from here to here, from here to here, so in fact it is 2 times 180-degree rotation, which is nothing but 360-degree rotation. Or in other words, what I can say is it's 2 times C2 operation, which can be written as C2 twice. And we can see this orientation and this orientation, they are just identical, not just equivalent, they are just identical. So therefore this C2 raised to 2, it is equal to E. Or this is true when we perform this n number of operations when n is even. So the outcome it will be the same even if we perform this operation for 4 times, 6 times, 8 times, and so on. So therefore we can say that Cn raised to n, that will be is equal to E when n is even. Okay, so this relationship Cn raised to n, that is equal to E, that relationship even it holds good when n is odd, right? So if the order of axis it is odd, and then we are performing it for odd times, then also this will be valid, right? So that can be just convinced from this example. Just to take the example for a molecule with n is equal to odd number, it is better we can go with BF3, where the order n it will be equal to 3 in this case, which is an odd number. So now when the axis odd, it is when the order of axis it is odd, we should, if we can perform the operation for say n number of times, of course n should be odd, and in that case again we what we get is 360-degree rotation itself we get, and it results in identical orientation that you can see here. See, F1 upon performing first operation, first C3 operation, F1 it takes this position, and after performing it for the second time, it takes this position, and after performing it for the third time, it takes this position. So in total, I have performed C3 operation thrice, and this can be written as C33. So C3 operation thrice, it is nothing but C33. And for that matter, Cn raised to n always it will be equal to 360-degree rotation. Therefore, it should result in E itself. But one point it should be taken care here. So this n, uh, n if I say odd, so this n it cannot be smaller than this. It should be definitely greater than this itself. That is one thing. And moreover, what I can say is this n it is in connection with this and not in connection with this. It is this n here, it is order of axis. Fine. Okay, now let us consider this operation. Sigma, if it is performed n times. Sigma operation, it is a reflection operation that we know, and here the relationship it says that sigma, if it is performed for even number of times, it results in E. See, from here to here, I have just performed the sigma operation once. So HA and HB, they have changed their position. So from here to here, one more time I have performed sigma operation. So that means in total I have performed sigma operation twice, or sigma operation even number of times. So sigma raised to 2, taking the molecule from this orientation to this orientation. So it can be said as sigma raised to 2, which has resulted in E, which we can find, right? So this operation, the results of this operation, that will be cancelled by this. Therefore, it results in identical orientation itself. So for that matter, now sigma raised to 4, even if I perform, it will be itself. Even sigma raised to 6, it results in E itself. So when n is even, sigma, if we perform it for n number of times, it results in E. Right? Same thing, it is not true when n is odd. Sigma, if we perform it odd number of times, it results in sigma itself. That can be seen here on the same molecule, water molecule itself. So once if I perform sigma, it has resulted in this orientation. Second time I perform sigma, it resulted in identical orientation, or this molecule and this molecule, it becomes equivalent. Here to here, if I check, it will be even number of times, and that's how it has resulted in E. But if I perform the sigma operation again, now what you can see is from here to here, when I am coming from here to here, I have performed sigma operation thrice, once, twice, thrice. So therefore n is equal to odd. And if I perform sigma operation for odd times, sigma raised to 3 here, just illustrative purpose, one example I have taken, that has resulted in sigma itself. See why this is sigma, you can just check. So this is original orientation HA, HB, this is HB, HA. So from here to here, right, directly even I can obtain this just by performing one sigma also. Or even if I do 3 sigma, I'll get same result. Or even if I perform 5 sigmas, I'll get same result itself. So therefore sigma raised to an odd number, or if sigma operation, if it is performed for odd times, the result outcome is just 1 sigma itself. Therefore sigma raised to n, that will be is equal to sigma itself. Okay, next we shall consider the same thing on inversion operation. So I raised to n, that is equal to E when n is equal to even. So now we shall see this relationship. So I, from this molecule benzene to this orientation, first orientation to this orientation, this is inversion operation. So if you do not know what inversion operation is, please watch my previous video, and so that you understand that. So each and every atom, it moves in opposite direction in all 3D, in respect to all 3 dimensions. So therefore this 5 it goes here, 2 it comes here, 1 it goes here, 4 it goes here, and the orientation it will be this. So this is the resultant when I perform I for once. So if I further perform I for one more time on the same molecule for the second time, so in total 2 times I am performing I, what I get is I get the original orientation back. If I call this as original orientation, this is first change in orientation. So this is second change in orientation because of I operations itself. So now in total from here to here, while moving from here to here, I have performed I operation twice, or I operation even times, so which has resulted in E. So same thing, it is true even if I perform I operation 4 times, 6 times, 8 times, and n is even, I raised to n, it results in E. Now something we can see it for when n is odd. N is what will be the outcome, that we should see. Same thing, same molecule I have taken, but I have performed I operation thrice. See this, first it changes the orientation, second time I perform, it gives me the original orientation back, and third time I perform the operation, so it results in this orientation 1 itself. If I call this as orientation 1, or say maybe this as orientation 1, this as orientation 2, orientation 3, orientation 4. See, if I perform I operation for 3 times, odd times, so it results in this orientation 2. So orientation 2, it can be obtained just by performing I once. So therefore, if I perform I from odd number of times, say from here to here, I have performed I operation for odd number of times, that is 3 times, has resulted in I itself. So when n is equal to odd, I raised to n, that will be is equal to I itself. Next operation, next symmetry operation, it is alternate axis of symmetry. So here one relationship I have, I'm taking it without, or I'm accepting the relationship without going to the proofs of that. So see, Sn raised to n. So Sn raised to n, it can be said that it can be just the product of Cn raised to n and sigma raised to n. So in fact, one S operation, if one S operation, it involves one proper rotation followed by reflection in perpendicular plane, that is S by definition, right? So now Sn raised to n means I am performing this improper axis operation for n times. So what I should say, it is rotation, reflection, again rotation, reflection, rotation, reflection. In that sequence it should be taken for n number of times. But what I am doing is, instead of performing the operation in this sequence, that is proper axis rotation followed by sigma, proper axis rotation followed by sigma for n times. So what I am doing is, I am taking this relationship as performing all those proper axis operation once, and sigma for n times for one more time, right? So in fact, in both way this operation it can be done, it results in the same thing. So therefore, instead of performing proper axis followed by sigma, proper axis followed by sigma, so mathematically what I am considering is that this Snn, it can be described as, first all n operations they have been performed once, then all sigma operations they have been performed once. So that is the meaning of this, right? So in that way I am considering this Snn operation. Again, for this molecule, now I have considered the molecule staggered ethane. So how this represents staggered ethane, that has been described while explaining improper axis of symmetry. So just you can watch that video. So now, so here Snn, it can be said as, so order of axis, in this case it will be the improper axis order, it will be S6. So S6, it can be said as C66 into sigma raised to 6, that I have not written. But from this definition, Sn raised to n, from this definition, say if it is S6 6 times, I should perform S6 operation for 6 times. In that case, it can be said as C66 into sigma raised to 6 times. So therefore, now what I do is, first I perform C6 raised to 6 or C6 operation for 6 times on this molecule. So on this molecule, C6 axis, it represents, or it says it is 60-degree rotation, and C66 60-degree rotation 6 times. So if I perform 60-degree rotation 6 times on this molecule, definitely this molecule, it will give you identical orientation itself, because this one atom, if I just consider, so on 60-degree, first 60-degree rotation, it comes here, somewhere here, right? And then next here, then next here, then next here, then next here, and it will return back to its original position. Similarly, all the atoms. So C66, it is essentially 360-degree rotation, which results in this orientation. Further, now I am performing sigma for 6 times, and we know this fact. Sigma, if we repeat it for even number of times, it results in identical orientation itself. So therefore, now these two operations simultaneously, if I consider, I can say that it is C66 into sigma 6, and from this definition, C66 into sigma 6, it can be written as S66, and S66, as you can see here, has resulted in E. So therefore, Sn raised to n, that will be is equal to E when n is even. Okay, now we shall see what is the result if Sn raised to n is equal to when n is odd. Just the change is that n, it is considered to be odd. The order of improper axis, it is just considered to be odd, right? So again, I'm mentioning, so here this is the n, whatever I'm mentioning, not with respect to this n. So it's with respect to this n. This is to be defined first. Based on this, the value of this, it will be fixed automatically, right? So this n, I'm talking about odd, if I say it is with respect to this n. Fine. Now, so in this molecule, if we know, this is again eclipsed ethane, which was taken as example for improper axis of rotation. What we have is S3 axis. In this case, S3 axis we have. So again, according to mathematical definition, S33 can be said as C33 into sigma 3. C33 into sigma 3, that should result in S3. So therefore, instead of performing S3 or S3, I'm taking it as C33 into sigma 3. So now on this molecule, if I perform C33 So again C33 it should represent 360 degree rotation, because C3 one C3 operation it says 120 degree rotation. Three such operations I have performed, so it should be 120 into 3, 360 degree rotation. So any molecule, if I rotate it by 360 rotation, I have exactly what I get is identical orientation itself. So no change in orientation, same orientation we get. Right now, further sigma it is to be performed 3 times. This is interesting. Sigma, if it is performed 3 times, I'll not get identical orientation. Orientation of molecule it changes from this to this. And sigma, if it is performed 3 times or for odd number of times, it is as good as performing sigma once. So therefore, on this molecule, if sigma is performed once, now very important thing, this axis CC axis, which we are not seeing, CC bond, that is C3 axis for this, or that is S3 axis 2 for this molecule. Perpendicular plane it should be perpendicular to this C3 axis. So that plane, as it was described in improper axis of rotation, it passes in between two carbon atoms. That plane, if we take sigma raised to 3, that will be is equal to sigma according to the previous relationship. So therefore, 1 sigma, if we perform this fourth atom, it takes this position, first atom it goes back. Similarly 2 5 exchange their position, C3 6 3 exchange their position. So what we get is that back carbon atom it will come to front carbon atom it goes to back. Right, so this orientation we get. Now you just observe from here to here, from this orientation to this orientation. So this can be straight away obtained by just performing 1 sigma operation 2. So therefore now, so here what I have described is from going here going here to here, I have performed C33 into sigma 3, or C33 and sigma 3 simultaneously have performed. So C33 into sigma 3 on from the mathematical definition it can be written as S33. So from orientation you can find that this is nothing but sigma. So therefore S3 3 times performed, that results in sigma. So that is the relationship. Right. So here the point is that all these relationships you should be convinced, especially in this topic. Convincing yourself it matters a lot. So neither by hearting helps you, nor reading or solving more examples that may help you a lot. The thing is, whatever you read little or whatever you understand, you should convince yourself each and every aspect. In fact, these relationships, they are very important when we go to the next part, where we see a possible number of operations on any given symmetry element. That aspect when we see, so in that case these relationships definitely they will be valid. And of course all these relationships, they can be mathematically proved either by taking XYZ points, or even further by matrix method. All these relationships it can be proved. But to begin with, we can just understand that yes, all these relationships definitely they are valid. Okay, hope this video it has given some idea about performing the operation for n number of times, or repeating operation. So if you have any queries, you can just write it in comment section. And if you have liked this video, you can give a like, and you can share this video. You can subscribe to our channel if it is not subscribed, and for future videos, fresh updates, you can press the bell icon. And thank you for watching this video. Thank you again.